Hey guys, it's John from THKP. Today we're going to be building Set, the card game. If you're not familiar with Set, that's totally fine. We'll describe all the mechanics of the game pretty soon. If you are familiar with it, you'll know that it's normally a multiplayer game. This is going to be kind of a single player version where you're racing against a timer. And in this particular video, we'll just be covering drawing the cards. There's actually a lot to cover, so I think I'm going to space it out between a couple different videos. But other than that, just sit back, relax, and enjoy, and let's begin. This is our starting point, and it's pretty simple. I'm going to go over all of this. We have an app. It wraps just a material app. And the home is just, I called it Set Home. And inside Set Home, we're just building a column layout where everything is centered. And inside of this column are two rows. So this is the first row, this is the second row, and each row consists of two cards. And this is the code for a card, this expanded thing. And this is just copied 4 times, so every single one of these cards looks exactly the same, just has a different text in the center. And there's nothing too fancy going on here. We just have a padding around the whole thing, so they're not touching each other. This aspect ratio is just the typical aspect ratio of a playing card. I might play with this a little bit later because set cards aren't shaped like playing cards, but I thought this was like a good place to start. And then the child of that is just a normal material card, so simple stuff. I've set an elevation here, I set the shape, I put this black border around the outside because I think it looks a little bit more aesthetically pleasing. And then I just have centered text inside here. So material cards are going to be doing a lot of the heavy lifting of rendering cards, but most of what we're going to cover in this video is the stuff that goes inside of the cards. So let's go ahead and jump into that. Set cards have these shapes drawn on them, and there's 4 separate attributes that you need to keep track of. You need to know which shape it is, so I'll call that shape type. And it's basically a diamond or this strange squiggly shape, or it's a pill looking shape. You need to know the texture of the shape, which I refer to as an outline. This is basically the center is not filled, or I call it banded, which is when the shape has stripes on it. Or we can have a filled shape, which is just a solid color. Then we have the color itself, which is red, green, and blue. And then we have the count of the shapes, which is either 1, 2, or 3, but I'm just going to represent that with an integer. So now I can create our set card class. Okay, so here's our set card. Now let's create a set card view whose purpose is to render these things. And this is going to look very similar to the cards we've already rendered. In fact, I'm just going to go down and copy that code. So let's take the aspect ratio, the padding, and whether it's expanded or not. I'm going to control all of that, outside of the card. But the card itself will know about its own aspect ratio. So let's start from there and copy. All right, and then let's just remove this widget because this is what we're going to be replacing, the actual body of the card. We're not going to just have centered text. We're going to have a column of shapes. And the number of shapes that are going to be in this column are based on the count of the card. So we can use list generate, we can use the cards count, which I don't actually have a card on this thing yet, so let's add that. So what list generate card count will do is it will generate a list of widgets, as long as we return a widget in this function here, that is equal to the size of count. So I'm going to create a widget called shape view, and this is basically going to be the funny little shape that gets rendered inside of the set card. So let's go ahead and just create that widget. And for now, let's just return a container, blue container. So in here, we need to say toList, otherwise we'll get some kind of type errors. And then we just need to close some parentheses. This is our set card view. Let's go ahead and use this instead of these 4 cards. So you can see that it's drawing 2 little blue boxes, and it's drawn them right at the top, which is not exactly what we want. So let's go back to our column and space them out evenly. And that looks pretty good. So if we want to draw 3, it would look something like this. Cool. So let's go ahead and replace the rest of our cards. Okay, and we're just drawing 3 blue boxes for every single card right now, but let's change these just so that when we do eventually write the code, it will actually draw 4 different cards. So instead of banded here, I'm gonna do outline, and I'll do diamond, and 3, that's fine. I'll do red. And let's do a banded squiggly. Squiggly is my favorite shape, so let's do a couple of those. Okay, so when we finally write the code to actually render all of these different shapes, let's do 2. It looks like I haven't done a 2 yet. There we go. So when we finally write the code to render these shapes, these cards will all look different and they should all look pretty cool. So let's go ahead and do that. So this is going to be in that shape view that we created a little bit ago. So I'm gonna go into our set card and down into our shape view. So let's throw in a custom painter here. The painter is going to be a shape painter. Let's create this class. Now we need to pass in what the shape actually is. So let's go ahead and do that. Okay, and we need these same fields inside the custom painter because the custom painter also needs to know about all this stuff. Okay, and then let's pass these in so that this stops rendering super strangely. Okay, we're getting the unimplemented error because of these 2 functions. So in here, we can just return, can pass a shape painter into here, and we can just say old delegate.texture is not equal to the texture. Okay, so we have 4 blank white cards because we're just not doing anything here. If I do something in here like, you know, draw rect, so now we basically have the same situation we had before. If I change this to green, for instance, it'll draw green. So this is the place where we need to implement all of our different shapes. So let's get into that. So in order to draw these shapes, we need a couple different pieces of information. We need the interior paint. So I will create a method to create the interior paint. And that will encode the color and texture of the inside of the shape. And then we need a border paint, which just paints the border, as you might guess. And we'll create a color map here, so I'll just say color map. And finally, we just want to add, for cases where edges join together or vertices join together, we want those to be rounded, because by default it'll kind of create these jagged edges. So I'll say round. Let's create this color map real fast. So let's create a get interior paint method. Here we switch on our texture, Filled and outline are pretty easy because we're just returning solid paints. The color here is just going to be from our color map. The color for outline is going to be transparent. And for banded, we're actually going to use a linear gradient. So the color is going to be the same, but the shader is going to be a linear gradient. And we will have to create a rect in here. And this rect will be based off of the size of the custom paint. So we'll do left top width height, 0, 0, size.width, size.height. And we'll have to pass in our size here. Now to set up this gradient, the begin and end are just the left and right side. The colors will create a method to do that. And the stops will create a method to do that as well. And this number that I'm passing into this method is just the number of bands that are going to be on the shape. So let's implement our get color first. We use a similar trick that we used before where we say list.generate. And we're going to generate the number of bands here. And for each band, we're actually going to return 4 separate items because each band consists of the beginning and ending of the stripe itself, and then the beginning and ending of a transparent stripe. So we're just returning a simple array of 4 different colors. We'll grab our color map color. And we want to return a single array here. So we just need to say expand, because this will return basically an array of arrays, where each item is this 4-part array. So we just want to expand this into a single iterable. And then we can say toList. And then at the end of this, since it ends with a color, I like to just add 2 transparents at the end so that it doesn't, I like it to start with transparent and end with transparent. So we can do that just by throwing in 2 transparents at the end. Okay, so that's our color, get color function. Let's change it to get colors. I think that makes a little more sense. And then we'll say get stops. This is going to be very similar idea here. In fact, we will just copy this. The difference will be that we need to actually calculate when the stop starts and ends. So instead of just returning an array here, I'm actually going to do a full method declaration. So we'll call it start, half, and end. This is going to be 4 double values. And what this means is, this is where the color starts. So this is a 0 to 1 value. This is halfway through the band. So basically where the color ends. We just want to repeat that value because that's where we want our transparent to start. And then this is where the transparent part ends. So it's the exact same pattern as up here, but it's just 0 to 1 values of where these colors start and stop. So let's calculate all these values. It's going to be the index over the number of bands plus 0.5. Now you ask, why is there plus 0.5? Well, because of this stuff. We basically have a number of bands and then we have half of a band at the end. So that's the idea here. The halfway point, actually let's calculate the end point first and then we can just calculate the halfway point by dividing the 2. So this is just index plus 1 over number of bands plus 0.5. And then the half is just the start plus the end minus the start over 2. And then for these last 2 values, the second to last value is going to be number of bands divided by the number of bands plus 0.5. And then the final value is just going to be 1.0. Okay, so now we have our paints set up. Let's see what these actually look like. So I'm going to scroll back up to where I'm doing my actual painting. And you can see I need to pass size into here. That should be okay. Now, instead of drawing a rect that's just the color green, I'm going to go ahead and use my interior paint. And you see that these 3 cards, nothing shows up. And that's because this 15 by 15 is not big enough to have the stripes. So if I say size.width, size.height, we should see something else. Now nothing shows up. Now this is because my custom paint is too large. In fact, it doesn't even have a size. It's just, if we go back up here, let's see where shape view is being rendered. It's just being rendered in a column, so it has no idea how big it's supposed to be. But what we want it to do is basically fill a rectangle that's not necessarily always the same size, because we want it to expand when the card expands, but we want it to always be the same ratio. Actually, we want it to always be the same aspect ratio. So we can actually use an aspect ratio widget here. This is a decent use case for one. You have a widget where you always want the height and width to be the same. You can use aspect ratio. So you can see here now that we have these nice stripes being rendered. I'm thinking this card is just an outline. In fact, let's verify that. We're not using our border paint yet, so let's throw in the border paint. Okay, cool. So yeah, you can see it's just rendering big rectangles, and it's using the interior paint and the border paint. Now we just need to finish the last part of the puzzle, which is the actual shape. So let's go ahead and do that. I'm going to create a function called getPath. We're going to pass in the size once again, similar to how we did with our interior paint. Just create it right here. And similar to what we did with paint, I'm going to switch on the shape. Okay, diamond is the simplest. In fact, we can just do that all in one line. So if you think about a diamond, it sort of starts halfway up the edge. So we can just say move to, so X would be 0, because we're on the left edge. And then the Y value would just be the height over 2. You can sort of see that halfway up the edge here. So 0, and then size.height over 2. And then we need 4 line 2 calls. Line 2. So this is going to be halfway along the top edge. So that's just going to be size width over 2, and then the Y is 0 because we're at the top. Let's copy this. We need another line 2. And this one is once again going to be halfway down the right side. So instead of width over 2, we're doing the full width. And then we just need one on the very bottom. So instead of 0 in the Y, we're just doing size, height in the Y. And then what we can do is just say close. And let's just return this same path for all of these different shapes. Okay, and let's actually use the shape itself. So instead of saying draw rect, we just say draw path. Here we pass in our shape. And then we basically do the same thing here, except border paint. All right, so we have some nice diamonds here. They look kind of janky. These lines are a little bit thick. We can play with that a little bit. If we go into get interior paint, we change this to 20, let's say. It looks a little bit better. One thing I like to do is make this value configurable based on the size, because if you have a massive screen, these might render very large, in which case, you'd want this number to be a little bit higher. Another thing that I think looks good is to just add a little bit of padding on the card. So let's do that just while we're fixing things. We can do that right inside this column. Oh, whoops, and instead of, okay, I need to put that around the column, not inside the children. So yeah, this looks a little better. And you can see a couple things that we did earlier at play here, like these edges are rounded a little bit. I just think that looks a lot better. Okay, so let's work on our next couple shapes. So for the pill, I like to think of the pill as two circles kind of connected by a rectangle. And once you think of it that way, it's actually kind of simple to implement this one. The first thing you need is a radius. And if you think of two circles on the very ends of a rectangle, the radius is just going to be the height of the rectangle divided by 2. So we'll move to the radius because that's where the shape is going to kind of start in the upper left corner, and the y is going to be 0. We're just going to draw the top line, so this is basically going to be size width minus the radius, and the y is still going to be 0. Now we need to draw some arcs. This is basically the point on the bottom right of the pill. This is the point on the top right. This is the point on the bottom right. And our radius here is going to just be the radius that we've already calculated. Okay, now we need to draw our bottom line. Once again, we need to draw 2r and then size height. And we need one more arc to point. This one's just going to be R0 once again, because we're joining back up with the beginning of the pill. And the radius is going to be the same as this radius. All right, so there's a nice pill shape. Now let's do the squiggly. The squiggly is much more complicated. I'm going to hop over to Inkscape. I downloaded this picture from the internet, and there are a lot of different ways you could model this, but the way that I chose to do it is with Bezier curves. And basically you have 4 separate points, and I'm just going to kind of eyeball this. It's going to look not super great, but hopefully it will show you the methodology at least. And then for these 4 points, the first thing is they're smooth points, meaning their control points all lie on some line, as opposed to having the 2 control points be able to be like pointed in different directions. Okay, so you can see the control points for this top vertex are slanted. The control points for the bottom vertex are basically slanted on the same line, so they're parallel to each other, the way that I modeled this. And then this side vertex, the 2 control points lie in a straight line up and down. And this, once again, this is going to look a little bit jank, but we'll play with it in the code. And yeah, so these are just in a straight line up and down. So we have 4 points, 8 control points. The outside control points just lie on vertical lines, but these inside control points both lie on this slant. And you can see that the points they're actually roughly where the diamond points are. They're kind of halfway up and down, halfway across, halfway up and down. You can see that they're like a little bit, they're not exactly in the middle. So we are going to see that in the code, but they are roughly where those diamond points were. So let's go back to our code. We'll bring our phone up and let's define all these points. So we'll start on the left side, call it P0. It's on the left side, so the X value is 0. And the height, we said before, it was almost in the middle, but it's a little bit offset. It's a little bit closer to the bottom than it is to the top, so I'm just going to use 0.665, or actually I'll use 0.6. Now let's do the top point. This is going to be size width times, and again, it's not in the middle, it's slightly offset from the middle, so 0.55. It's also not right at the very top, so let's do size height times 0.15. And then the other points are just kind of the mirror images of these 2 points. So size width, and then instead of 0.6, we're going to say 0.4, because it's kind of a parallelogram. And 0.3 is width. Now not 0.55, it's 0.45, because it's flipped. And the height is going to be 0.85. Now I mentioned before that there's a slant involved here. Both of the, or all 4 of the control points of the interior, top and bottom coordinates are on the same slant, so I'm going to define that slant. We'll just say 0.6, that's about 30 degrees. That's sort of what it looked like to me. And then we can define all of our control points. CP0. CP0 is going to be based off of the first point, and it's just up from the first point. And as mentioned before, like they're all on it's all on a vertical line. So this is 0. It's literally just moving upwards. And you know, it's negative because the lower the Y, the higher. It's just how the coordinate system of these custom painters work. CP1. This is going to involve that slant that we talked about. So it's going to start at P1, and we're going to subtract the slant times, and this is going to be based off of the height, times 0.8. CP2. Now, by the way, all of these values are things that I played with a little bit. So if you're wondering where I'm coming up with these magic numbers, I just sort of tweaked it until it looked pretty good. So this goes in the opposite direction. So instead of minus, it's going to be plus. And then instead of 0.8, it's going to be 0.5 because it doesn't go as far. And then we got CP3. It's going to be P2. So it's starting from the right edge. And once again, it's just going to move straight upwards times 1.1. Now the last 4 coordinates are actually just the mirror images of these 4. So I'm just going to copy them over. I've already written them all out. Okay, so we have everything we need in order to build our squiggly. So let's go ahead and do it. We're going to start with a path just like the other ones. And we're just going to move to our first point. In a lot of ways, this part's actually easier than the other shapes just because we've already defined all of our points. So it's just going to be 4 cubic Beziers. What this means is it moves to P1, and these are the 2 control points. So first control point, second control point. So now we want to move to P2, we want to move to P2, and the control points are going to be 2 and 3. And now we want to move to P3. These are going to be 4 and 5. Probably seeing a pattern here. And then we're going to move to P4. Or, sorry, there is no P4. We're going to move back to P0. And this is 6. And this is 7. It's just a nice, chunky, squiggly line. So it looks pretty cool. And that's really about it. Let's add a couple more cards just so you can see this is like a little bit flexible. So let's throw another card in the top row. We'll make it a filled diamond and blue. Let's just make it. And then we'll just go ahead and add another card to the bottom row. All right, so there you have it. Here's some nice set cards. And in the next couple videos, we'll talk about some of the animations for this game, the timer, a lot of the logic for calculating whether something is a set or not. It's all really fun algorithms, so I hope you stay tuned for that stuff. If you enjoyed the video, please like and subscribe, it helps the channel. And other than that, have a wonderful rest of your day, and I'll see you in the next one. Bye-bye.